So there is this important theorem that tells us that a first-order sentence that does not contain any equality can be converted to an equivalent sentence in conjunctive normal form. So the conjunctive normal form in first-order logic is similar to the conjunctive normal form in propositional logic. Just like in propositional logic, a CNF first-order logic sentence is a conjunction of one or more clauses, and each clause is a disjunction of one or more literals. Now, the difference here is that in first-order logic, the literals may contain variables. When they do, these variables are always assumed to be universally quantified. So there are 6 steps that we need to perform to convert a knowledge base to conjunctive normal form, and we have to perform them in order. The first step is to eliminate biconditionals and implications, and we do that using the implication elimination rule from our toolbox. Step 2, we move not inwards, and we can do that by using De Morgan's law from our toolbox, but we can also do that by using the properties of the quantifiers that we just saw. So in most cases, we have to use both of these things to make sure the nots are with the literals and not outside the clauses. Step 3, we have to standardize the variables. Each quantifier must be associated with a different variable. Step 4, we scholemize. Each existential variable must be replaced by a scholim function of the enclosing universally quantified variables. If there's no enclosing universally quantified variable, then the existential variable must be replaced by a constant. Step 5, we drop all universal quantifiers from our sentences. And step 6, we apply distributivity. We distribute or over and that's also applying one of the equivalences from our toolbox. Let's make sense of this with an example. Consider the sentence, "Everyone who loves all animals has a pet." That sentence in first-order logic can be written as, for all x, for all y, animal y implies loves xy, implies there exists z, pet zx. So anyone who loves all animals has a pet. I added these brackets here so that we are clear on what implies what. It's this whole implication that implies this. And the scope of the universal quantifier for all here is actually the whole sentence because we have an x here. All right, so how do we convert this sentence to CNF? Step 1 tells us we have to eliminate biconditionals and implications. So we use our implication elimination rule that tells us that we can replace alpha implies beta with not alpha or beta. Now our alpha is this whole thing here. The alpha does not include the for all x because the for all x applies to the whole sentence. And our beta is this sentence here. There exists z, bet zx. So applying this, we get for all x, not for all y, animal y implies loves xy. This is the not alpha, or beta, and our beta here has not changed. Note that the for all x is on the outside because it's not part of the alpha. Now we have a second implication. We have eliminated the first implication here, but we still have this implication that we need to eliminate. So we focus on this part of the sentence here. And again, our alpha is animal Y and our beta is loves XY. So to get rid of this implication, we write not animal Y, not alpha or beta. And the rest of the sentence does not change. Here again, the for all Y is outside because the scope of this quantifier is the whole sentence. There's a Y here. All right. So that was step 1. Step 2, we need to push the knot inwards. So where do we have knots that can be pushed inwards? We have this knot here that is outside this disjunction. So let's see how to push it. We know that not for all yp is equivalent to there exists y not p. So let's apply this to our sentence. We get, instead of not for all y, there exists y not. This is our p here sentence, and we put the not in front of the whole sentence. So there exists y not p, and this part of the sentence has not changed. Now we still have this not that needs to be pushed inwards, and this is where De Morgan's law is useful. We have not P or Q is equivalent to not P and not Q. So applying this, we get not animal Y and not loves XY. Don't forget to replace the or with an and when you apply De Morgan's. And this part has not changed. And now not animal is actually animal. We have a double negation elimination. So we end up with this sentence, not X, there exists Y, animal Y, and not loves XY, or there exists Z, bet ZX. So we're still in step 2. We're not in CNF yet. Step 3, we need to standardize variables. Each quantifier must use a different variable. So here we have 3 quantifiers, the for all. The variable associated with it is X. We have a there exists, and the variable associated with it is Y. And then we have another there exists, and the variable associated with it is Z. So it looks like here our variables are already standardized. Each quantifier is already using a different variable. So for this example, we don't need to do anything for step 3. Step 4, we need to scholemize. So each existential variable must be replaced by a scholim function of the enclosing universally quantified variable. So we have 2 existential variables here, y and z. We're going to replace them by functions of the enclosing universally quantified variables. So there is a single enclosing universally quantified variable here, it's x. So we should replace y with f of x. Can we also replace z with f of x? No, we can't, because y and z are 2 different objects. So what we do is we replace z with a different function of x. So we replace y with f of x and drop the existential quantifier, but then we have to replace y with f of x in the whole sentence. And for z, we replace it with g of x in the sentence, and we drop the existential quantifier here. All right, so that was step 4. Step 5, we drop the universal quantifier. So our sentence becomes animal f of x and not loves x f of x or pet g of x x. And step 6, we distribute or over end. So we have this and this OR. We're going to distribute the OR pet g of x over the animal f of x and not loves x f of x. So we get animal f of x or pet g of x and not loves x f of x or pet g of x. All right. And now we are in CNF.